Right now, as you are watching this, the Atlantic Ocean is running hotter than almost any point on record for this stretch of the calendar. Off the coast of Florida, sea surface temperatures are sitting several degrees above the seasonal average. In the Gulf of Mexico, monitoring buoys are logging numbers that typically don't show up until deep August. And out across the central Atlantic, the stretch of ocean scientists call the main development region, the water where most of the strongest hurricanes are born, is running warmer, earlier, than it has in decades of satellite record-keeping. NOAA and the National Hurricane Center have both flagged this anomaly in recent weeks, saying the extra heat is loading the ocean with the one ingredient that can turn an ordinary tropical system into something far more dangerous, far faster than forecasters are used to. This is not a single storm story. This is an entire basin story. To put it in context, the same warm water signature that sat underneath several of the fastest intensifying hurricanes of the last decade is now spread across a wider stretch of ocean than usual, at an earlier point in the season than usual. Today we are going to break down exactly what is happening beneath the surface, why warm water is the single most important variable in how fast a hurricane can strengthen, and whether the numbers we are seeing right now mean this season could produce a storm that intensifies faster than people have time to prepare for. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you personally ridden out a hurricane that intensified faster than forecasters expected? Tell me where you were and what it felt like. If you want to be the first to know every time something major develops, subscribe. It is completely free, and a thumbs up helps enormously. Let's go for 5,000 likes on this one so the algorithm actually shows it to the people who need to see it. Now, let us get into it. Ocean temperature does not move in straight lines, which is exactly why this year's numbers have drawn attention from people who study this for a living. Through the late spring, sea surface readings across the tropical Atlantic began pulling away from the long-term average earlier than usual. By early summer, several independent tracking sources, NOAA's Optimum Interpolation dataset among them, were showing broad stretches of the basin running 1 to 2 degrees Celsius above the 1990 to 2020 average. That may sound small. It is not. A single degree of ocean warming, spread across millions of square miles and dozens of feet of depth, represents an almost unimaginable amount of stored energy, and hurricanes are, at their core, heat engines. They exist to move that energy from the ocean into the atmosphere. Give the engine more fuel, and it does not always mean a bigger storm. Sometimes it means a faster one. Forecasters have already been watching this pattern play out in real time this season. Multiple systems that formed over the anomalously warm patches strengthened at a pace that outran the official forecast models, not by a small margin, but by intensification rates that the National Hurricane Center itself has flagged as unusual. That changed fast. In several of these cases, a storm that was a moderate tropical system in the morning advisory was a major hurricane by the evening advisory, a jump that used to be rare enough to make headlines on its own and is now becoming something forecasters have to actively plan around. The technical term for this is rapid intensification, an increase in maximum sustained winds of at least 35 miles per hour within a 24-hour window. A decade ago, that threshold was crossed by a handful of storms each season. In the last several years, it has been crossed by a meaningfully larger share of Atlantic hurricanes, and this year's ocean heat signature is one of the clearest indicators forecasters have that the pattern could continue. To understand why this matters so much, you have to understand what a hurricane actually needs to grow. Warm ocean water evaporates faster, pumping more water vapor into the air directly above the storm. That vapor condenses into towering thunderstorm clouds inside the hurricane's core, and condensation releases heat that lowers the air pressure at the center of the storm even further, which in turn pulls in more air, which evaporates more water, which releases more heat. It is a feedback loop, and warm water is the fuel that keeps it spinning. The official threshold most forecasters use is 26 degrees Celsius, roughly 79 degrees Fahrenheit, measured through at least the top 50 meters of ocean. Below that number, a hurricane starts to starve. Well above it, and significant patches of the Atlantic this year are running 2, sometimes 3 degrees above that already generous threshold. The storm has more energy available to it than the atmosphere around it can efficiently vent away. That surplus energy is what shows up on radar as a storm that intensifies overnight instead of over 3 days. If you follow hurricane news at all, a handful of names from recent seasons probably already ring a bell. Storms that went from a name most people had never heard of to a catastrophic landfall in a span of hours, not days. Those storms shared one thing in common before anything else: unusually warm water sitting directly beneath their path at the exact moment they needed it most. This year, that same kind of warm water is not confined to one small patch waiting for a storm to find it. It is spread across a wider footprint of the basin, sitting there before the peak of the season has even arrived, which is precisely why NOAA's own seasonal outlook and independent university forecasting groups have both leaned toward an above-average season, with an above-average number of storms reaching major hurricane status. None of this guarantees any single storm will strike any single coastline. It does mean the raw material for a fast, dangerous intensification event is more available in more places than it typically is at this point in the year. The difference between a coastline that survives a rapidly intensifying storm and one that is devastated by it is not luck. It is preparation, warning time, and infrastructure, and that gap has shown up again and again in recent hurricane seasons. When a storm strengthens slowly, forecasters can issue watches and warnings days in advance, emergency managers can stage resources, and residents have time to make a real decision about whether to evacuate. When a storm undergoes rapid intensification close to shore, that entire timeline collapses. Communities that would have had 72 hours of warning sometimes get less than 24. In some of the most severe recent cases, the difference between a storm arriving as a strong tropical storm and arriving as a major hurricane happened within a single overnight period, while most of the population most at risk was asleep. This is not an abstract risk. Coastal regions along the Gulf and the southeastern seaboard have some of the fastest growing populations in the country, and a significant share of that growth has happened in flood-prone areas built after the last major storm to strike that specific stretch of coast. Many of the people now living in these zones have never personally experienced a major hurricane landfall, which means their mental model of how bad it can get is built on second-hand information rather than lived memory. Emergency planners describe this as one of their hardest problems, convincing a population that has not been tested that a storm intensifying overnight is not a hypothetical, but a documented, recurring pattern in the exact waters those communities sit beside. These are not just meteorological events, they are human experiences, measured in evacuation routes that clog in hours instead of days, in shelters that fill faster than expected, and in the gap between the warning a family receives and the time they actually have left to act on it. Emergency management agencies have responded by shifting their own messaging in recent years, moving away from waiting for a storm to reach major hurricane status before urging evacuations, and instead building plans around the possibility of rapid intensification from the moment a system organizes. Some coastal counties now trigger evacuation orders based on ocean temperature and storm track probability rather than waiting for the storm's current category, precisely because the lag between "this could get much worse" and "this got much worse" has been compressed by exactly the kind of warm water currently sitting across large stretches of the Atlantic. Keep an eye on how far in advance the watches and warnings come out this season, too. That timeline itself has become one of the clearest real-world signals of how seriously forecasters are treating the ocean conditions behind the scenes. So where does that leave the rest of this season, and what exactly are scientists watching next? The single number every major forecasting group is tracking is ocean heat content. Not just the surface temperature, but how deep that warm water extends. A thin layer of warm surface water can be churned up and cooled by a storm's own winds, which sometimes weakens a hurricane as it moves. But when the warmth extends 50, 100, even 150 feet down, a storm's own wind-driven mixing pulls up more warm water instead of cooler water, and the storm keeps feeding instead of starving itself. Ocean heat content across parts of the Gulf and the Western Atlantic has been running unusually deep this year, which is exactly the setup that forecasters associate with sustained rapid intensification rather than a single lucky burst of strengthening. Beyond the water itself, forecasters are also watching the broader atmospheric pattern, how much wind shear is present across the basin, since strong upper-level winds can tear a storm apart even over warm water, and whether this year's large-scale climate pattern, whether leaning toward El Niño or La Niña conditions, tends to suppress or encourage storm development. The current outlook from NOAA's Climate Prediction Center has leaned toward conditions historically associated with a more active Atlantic season, which, layered on top of the warm water anomaly, is why independent forecasting teams at institutions such as Colorado State University have also nudged their own seasonal storm counts upward. None of these signals, on their own, tell us where the next major storm will make landfall. Together, they tell us the ocean is primed, in a way it has not consistently been primed in prior seasons, for whatever storm does form to intensify quickly once it gets the chance. So let's resolve the fear this video opened with, because it deserves a straight answer. Is the Atlantic Ocean waking up in some unprecedented, unrecoverable way? No, there is currently no scientific evidence that this year's warm anomaly represents a permanent break from natural ocean cycles, rather than an intensified version of patterns scientists have already documented and studied for decades. Scientists generally do not conclude that a single warm season, by itself, proves a runaway shift in ocean behavior, and no credible forecaster is claiming that. But here is the part that actually matters for anyone living along the Gulf or the Atlantic coast. The real, closer danger is not some abstract shift in the ocean's long-term temperature. It's the much more immediate reality that the water sitting off your coastline right now has more of the exact fuel a hurricane needs, at a point in the season when people are least prepared for a fast-moving threat. The supervolcano-scale panic isn't the story here. The story is that a storm forming over water like this can go from watch the news tonight to evacuate tomorrow faster than most families' emergency plans are built to handle. To put the season in context one more time, above-average ocean heat, above-average heat content at depth, and a seasonal atmospheric pattern that forecasters associate with more active years, all three signals pointing the same direction at once, is not something that happens every season, and it is exactly why NOAA, the National Hurricane Center, and independent university forecasters have all converged on the same warning this year. Not, this will be the worst season ever, just, the ocean has the fuel loaded, and when a storm arrives, it may not give you the multi-day runway of warning you're used to. So drop that comment I mentioned earlier if you have not yet. Have you lived through a hurricane that intensified faster than the forecast said it would? Your story helps the next person understand this is not theoretical. And if this kind of documentary, grounded in the actual science, not the panic, is something you want more of, hit subscribe, it's free, and let's actually hit that 5,000 like goal so more people see the real explanation instead of the scariest headline. Let us go. See you in the next one.